energy that keeps it shining. The size and brightness of the star depend on its mass, with larger stars being hotter and more luminous than smaller ones. As a star exhausts its hydrogen fuel, its core begins to contract and heat up. This causes the outer layers of the star to expand and cool, turning the star into a red giant. The red giant phase is one of the most visually striking stages in a star's life cycle. During this phase, the star's outer layers may extend out to several times its original size, making it much larger and brighter than before. Eventually, the star will run out of fuel altogether and begin to die. During this phase, the star expels its outer layers of gas and dust in a process called a planetary nebula. The gas and dust that are expelled from the star form a beautiful, glowing cloud known as a planetary nebula. The core of the star is left behind and is known as a white dwarf. A white dwarf is the final stage in the life cycle of a star. It is a hot, dense object that is about the size of the Earth but contains the mass of a star. White dwarfs slowly cool down over billions of years until they become cold, dark objects known as black dwarfs. The life cycle of a star is a fascinating journey that has captured the imagination of scientists and astronomers for centuries. Studying the life cycle of stars is essential to understanding the universe in which we live and our place within it. The study of stars has led to many groundbreaking discoveries in astrophysics, and there is still much to learn about these beautiful objects. One of the most fascinating aspects of a star's life cycle is the fact that stars are constantly changing and evolving over time. As stars age, they undergo a series of transformations that alter their physical characteristics and behavior. One key factor that determines a star's life cycle is its mass. The more massive a star is, the shorter its lifespan. This is because more massive stars burn through their fuel much more quickly than smaller stars. In addition, more massive stars have much stronger gravity, which can cause them to collapse more rapidly at the end of their lives. Another important factor is a star's composition. Stars that are rich in heavier elements tend to have shorter lifespans than stars that contain primarily hydrogen and helium. This is because heavier elements tend to produce more energy during nuclear fusion, causing the star to burn through its fuel more quickly. As stars age and their hydrogen fuel is depleted, they begin to burn helium in their cores. This marks the beginning of the end for most stars, as they begin to undergo a series of transformations that ultimately lead to their demise. Some stars end their lives as supernovae, which are incredibly powerful explosions that can briefly outshine entire galaxies. These explosions occur when a star's core collapses and then rebounds outward, expelling its outer layers in a massive burst of energy. The remaining core of the star can then become either a neutron star or a black hole, depending on its mass.